Now let's look at some multiplication examples. One example we see often when we're working with fractions that involves multiplying is when we're asked to find a fraction of something. Let's look at an example. Susan is 60 years old. Her daughter is 2/3 of her age. Find her daughter's age. Now this problem often confuses people because when they say her daughter is 2/3 of her age, many times people think they ought to divide. Let me show you what would happen if we tried to do that problem by division. If we took 60 and divided it by 2/3, we'd have to make the 60 look like a fraction and put a 1 under it. So we'd have 60 over 1 times 3/2 because we invert and multiply. And then we'd start to reduce here. And then when we multiply it across, we'd get 90 over 1, or 90. Now we know something was wrong because Susan is 60 years old. Find her daughter's age. Her daughter certainly couldn't be 90. So that's a case where if you do the wrong operation and look at your answer and see if it's sensible, you'll decide right then that you did the wrong thing. So we know it's not division. It's never going to be division when you're finding a part of something, a fraction of something. Here's the key. We're interested in 2/3 of her age. The of, in this case, means to multiply. Sometimes the word of is just a preposition in a sentence, but when you're looking for a fraction of something, it means to multiply. So let's come over here and do the multiplication. If we take 60 and multiply it by 2/3, we need again to put a 1 under the 60. But this time we wouldn't invert anything, and I'm going to kind of separate this from this so we won't get it mixed up. This time we won't invert anything because we won't find the reciprocal because we're multiplying. And in multiplying we need to reduce. So we say 3 into 3 one time. 3 goes into 60 20 times. Then 20 times 2 is 40. 1 times 1 is 1. And 40 over 1 is just 40. And we're talking about her daughter's age. So her daughter would be 40 years old. And if we go back and look at the problem, that's sensible. Susan is 60 years old. Her daughter is 2/3 of her age. Her daughter would be 40 years old. So remember, if you're looking for a fraction of something, you multiply. We deal with problems that involve finding fractions of things so often that I thought it was important enough for us maybe to look at one more problem. This one deals with a recipe. A recipe calls for 2½ cups of flour. How much flour is needed for 1/3 of the recipe? In other words, we might get ready to make cookies and we need to have 2½ cups of flour, and we don't have enough flour, so we decide, well, we'll still make some cookies, but we'll just make 1/3 of the recipe. So if we wanted to make 1/3 of the recipe, how much flour would we need? Now see, again, we're interested in finding 1/3 of the recipe. Here's that word of again, and it's what we're looking for. We're looking for a fraction of the recipe. So we're going to take our 2½ and multiply it by the 1/3. Now actually, since it's multiplying, you can do it in any order, so we could have written down 1/3 times 2½ and it would have been just as correct. Now, in order to be able to multiply, we have to make mixed numbers into improper fractions. 2 times 2 is 4, plus 1 would give us 5/2 times our 1/3. So if we look at that, to see if we can do any reducing. You'll see that there's nothing that we can reduce, so we just go ahead and follow our multiplying rules. Multiply top times top, or numerator by numerator, and get 5. And denominator by denominator, 2 times 3, and get 6. So, for our recipe, we need 5/6 of a cup of flour. So if we were actually making cookies and we're going to use 5/6 of a cup, what we'd probably do is just realize that that's almost a whole cup. 6/6 would be a whole cup. So what we do is we get our measuring cup, get our cup measuring cup, and just fill it almost full. Just leave just a little bit less from the top, and kind of estimate to get what 5/6 is. And then we can make our cookies. So this was another example of when we were finding a fraction of something. Let's look at another problem. Jerome is buying turkey for the weekend. If each person eats 1/3 of a pound of turkey, how much turkey will he need to buy to feed 10 people? So what we're saying here is that the first person would eat 1/3 of a pound, the second person would eat 1/3 of a pound, the third person would eat 1/3 of a pound, and so on till we used up all 10 of those people. So one way to figure out the answer would be to write 1/3 down, ten times. We'd write down 1/3 until we got 10 times and count up how many thirds we'd have. And as you can guess, we're going to have 10 thirds. And that would really give us our answer. What we're actually doing, though, when we write that 1/3 down 10 times, we're adding 1/3 to itself 10 times, or we can say we're multiplying 1/3 times 10. So this is an example where we're repeatedly doing the same thing over and over. In other words, each of those 10 people are going to eat 1/3 of a pound. So we're repeating that 1/3 10 times. When you have repeated addition, or you're doing the same thing over and over, you can solve the problem by multiplication. So let's do that. Put a 1 under the 10. There's nothing we can reduce, so we end up with 10 thirds. And so we can tell how much turkey we need to buy. We need to divide that out. And when we divide that out and turn it back into a mixed number, 3 goes into 10 3 times, and we have 1 left over. So we'd have 3 1/3, and it says how much turkey will he need to buy. So this is the turkey that we're buying, and it's measured in pounds. So we'd need 3 1/3 pounds. 3 1/3 pounds of turkey is what you need to buy to feed the 10 people. Now what I want to do is to take a problem that involves the same numbers in it, the 1/3 and the 10, and we're going to still be talking about turkey, but the 10 is going to refer not to people this time, but to pounds of turkey, and I want to show you how we can change the problem just a bit, and it will no longer be a multiplication problem.